Good afternoon. My name is Rich Nass, and I am here for another session of 5 Minutes With. And today's guest is Niall Cooling, CEO of Feabhas. I said that wrong, didn't I, Niall?
That's good enough.
Okay. How are you, Niall?
I'm doing pretty well, yeah. And yourself?
So Niall's claim to fame is that he's a consultant and he's a trainer for people in the embedded software space. And I know I'm selling you short. You're much more than that. But for the context of this discussion, let's just go with that.
Sure.
We have 5 minutes, so I'd like to get right into it, if that's okay with you.
Of course.
Okay. So you are very much in the embedded space, and as I am as well. Embedded means a lot of things to a lot of people, and I won't get into the discussion of what is embedded because I think we've done that one to death. But how has embedded changed over the years? I've been embedded probably for 20-some-odd years, and I could tell you how I think it's changed, but you have a much better handle on it. What is embedded today as to what it was 20 years ago?
I think from what we see is what I generally call the platform is changing. You go back, said many years, and you were very typically close to the metal, the bare metal type systems, and even the RTOS-based systems were few and far between at that point. So the abstraction layer for the programmer was very, very low. And of course that has been changing, and the significant changes we see it was with Linux entering the market in the sort of late 90s, certainly into the early 2000s, and with the ARM-supported processor platform, that's pushed that abstraction layer up for what you can build an embedded system with massively. And this big grey area now you have between what can you do on the desktop and what is embedded, I think is very much driven by that abstraction. That's also happening now, I think, in the deeply embedded side. You've got, it started with the Arduinos. ARM have been pushing their embed, and we're seeing things like, MicroPython and embedded Lua trying to make that programming model easier to build embedded systems and not have to have such a detailed knowledge of the hardware aspects from an abstraction. So that's certainly, we've seen that change. Things like Linux have made a big change. Okay,
so that leads us into another topic that I want to talk about is this whole invasion of operating systems that people, in theory, don't have to pay for, like Linux, Android, free RTOS. Do you work with those, and do you recommend them to your customers? And if so, what's your take there?
It's an interesting one because I think a lot of people always said that free is only free if your time is free, and actually for most people, I think the most valuable commodity is time. And people, engineers are, they're expensive. So this is where we're seeing is the effort and the support. If you compare, say, take the RTOS area, obviously there's massive support for RTOS, very well supported, very well used, and it's very difficult to knock that compared to many other real-time operating systems. But then it's the depth of support you're going to get. Richard Barry's a very good guy; he really has good support out there. But you compare it to like a Wind River VxWorks, and the depth of support and the platform support you're going to get from that naturally is going to be broader. And again, Linux has changed that. That availability of people getting in there is the only downside I've seen from some of the free stuff, and this is more possibly around the library area that people try and use, is where we've seen some people come unstuck by taking on software that they see as free, and it's the guarantee of quality. I think is that problem. Is if it's free, then where's the value in it, and does it devalue the product? Does it devalue what we do as a job? Is very difficult, but it's certainly changed the marketplace massively. Recommending it, I think it's like all things, you've got to put it in a context of the type of system somebody's building. And we've seen a lot of people hugely successfully use things like Linux, but you've got to put in the context now, I think, especially if we're connecting everything to the web, is the security aspects and trying to manage in an embedded device where field updates can be harder, is how you're going to keep things like the kernel and the build up to date. And you can argue the other side, we've had security through obscurity with real-time operating systems, but that is true to an extent. It's a smaller vector for people to attack. So I think like all things, there's pros and cons, but certainly they're here to stay. And they do a very good job, without a doubt, for many people. They're perfectly fine, and probably better than people doing it themselves. I'd still go back on that. I'd certainly recommend them over somebody rolling their own kernel in this modern time.
Okay, fair enough. But that brings up, because a lot of these free operating systems are not well documented, is that a good thing for somebody who's in a business like yours?
Yes and no. I mean, what we generally try and do is not focus on an individual product as such, and try and give the education around the core knowledge. So, like real-time operating systems, you could argue that if you compare all of them, however many there are, fundamentally they're doing the same job. They offer certain abstractions in terms of, a task thread model. They offer, mutual exclusion through things like semaphore and mutexes. So the principles of many of them outside of, say, RMA are very, very similar. And that's what we're sort of generally trying to teach, is the conceptual model of, how do I do it? What are the principles of threading and where is it safe to use it, as opposed to a particular API. But I mean, and we always would recommend for anybody, they should build an abstraction layer for their organization, so they don't ever rely directly on an API. They're always working to a more abstract one. And of course, Linux has the benefit that you've got the P thread, and now with C++11, you've got threading in the language, and I think that's going to change that model as well. But it does mean that the downside of that is people, if they've only ever worked with, say, one operating system, they sometimes have quite a misunderstanding of some of the core principles of how things work, signaling or mutual exclusion. They only know one model, so that's they think the whole world is that way, and it's sometimes trying to re-educate those people can be quite difficult.
Okay. Unfortunately, we've used up our 5 minutes. But my takeaway from this, when I ask you if you recommend somebody uses a free RTOS, maybe. Is that accurate?
Yeah, I mean, as long as they've got the time to invest in it. I think that's what it comes down to, is, except there is going to be more time required to get to know it in more detail than you may do for a commercial off-the-shelf system.
Very good. Well, thank you very much, Niall. I appreciate you taking the 5 minutes to talk to our readers. Have a great day, Niall.
Thank you very much, Rich.